Welcome to our video on miscellaneous measurements. So how about volumes of solids? Well, we've got kind of a family of solids. We have things that are called right rectangular prisms, which are basically any kind of shoebox shape, but really these can be generalized. You can really consider anything that has a base and then perpendicularly vertical walls to that base can be considered a right rectangular prism. So a right circular cylinder is just a version of a right rectangular prism, which is why you see they both have the same formula of volume equals base times height, volume equals base times height, right? Because they're both following the rule of they have a base and then the walls are perpendicular, right? Perfectly parallel to that base. Whereas these aren't, right? So the walls slant in. So that's why they're no longer just volume times base. They're 1/3 of base times height. Sorry, I said volume times base. I meant base times height, right? Their volume is no longer just base times height. It's 1/3 of that because of the slanted walls. So a pyramid and a circular cone are the same thing. Calculate the area of the base. In this case, some sort of rectangle or maybe a square. In this case, a circle. Then the height is always the vertical height, right from the middle up to the tip top. And then 1/3 that is going to be the area of these two shapes. Calculate the area of the base, in this case a circle, in this case some sort of rectangle. Multiply that by the height, and that is your volume of those. And then of course the sphere is just, different from everything. And that's just 4/3 pi r cubed. And then of course your surface area is 4 pi r squared, which again is the derivative of this, just like circumference is the derivative of area, surface area is the derivative of volume. Kind of nice how that works with circles. And then surface area for all of these things get very complicated because of the angles, right? So you get all these square roots and weird stuff. Surface area of this is really easy because remember it's just the two circles plus the skin, which is a rectangle, and then here you're just adding up all those bits and pieces. So you can find the volume of this nice cylindrical fish tank if you know its dimensions, its height and its diameter, by plugging it into the simple formula of area of the base times the height. And you could leave it in terms of pi, or you can get an approximation. How about the surface area and volume of this 12-inch globe? Well, again, we can use those formulas for surface area, plug in the piece, or volume, plug in for radius, right? So it's really just a matter of having a boatload of formulas and plugging numbers into them. That's really the gist of most of this video, right? Formulas, formulas, formulas. So if you just want to write down all of those, that's pretty much it. All right, so let's look at a few more examples. Surface area, volume of the glass. Well, you'll notice that glass, we're obviously talking about just the glass part, not the stem, right? So this glass part ends up being a right circular pyramid, right, or a right circular cone. So we can use the surface area formula for that, plug everything in. We can use the volume, which remember is just 1/3 base times height, plug everything in for that. All right. How about some comparisons? So this is really just looking at volumes of similarly shaped figures. So you can look at the sides of a square and its area versus circles and area of those things. And then if you increase the radius of a sphere, what does it do to the area? Well, you have to remember that the radius is being cubed, so any increase in the radius gets cubed, right? So if you double the radius, the area, the 4/3 pi r cubed, right? The volume goes up by 8 times. These should be V's, not A's, because these are really volumes. You can also look at the difference between mass, which is weight, and temperature from our system and the metric system. So pounds and tons, right? A ton is 2,000 pounds. We've got kilograms and everything based on powers of 10. Here's some basics. You know how much 5 pounds is 2.3 kilograms. 22 pounds is 10 kilograms because I mentioned in a previous video that the conversion from metric to US for weights, for masses, is 2.2 pounds per kilogram. Temperature, well, there's Fahrenheit, which is the US system, and then there's Celsius, the one that everybody else uses. Ours makes no sense whatsoever. Why does water freeze at 32 degrees and boil at 212? Wouldn't it make more sense to have those be normal numbers, like freezing at 0 and boiling at 100? So that's what the metric system did. And so that's where the conversion between those two systems comes from. And we don't have the formula here, the specific formula, but the basic, you know, if you're traveling, let's say in Europe or really anywhere, and you're looking at the weather reports, a U.S. temperature, if you want to convert metric, so they tell you like tomorrow it's going to be 15 degrees, and you're like, oh God, is that cold? Is that hot? Basically, take the metric, right? Times it by 2, and then add 30, and that gives you a gross approximation to Fahrenheit, right? So if you had 15 degrees Celsius, you would double it, which gives you 30, then you would add 30, and that would be about 60 degrees Fahrenheit. It's not precise, but it's close enough to let you know that, okay, 60 degrees, you know, you can get away with maybe shorts or long pants depending on, you know, how cold-blooded you are. But that's a really easy kind of approximation for getting Fahrenheit out of a Celsius temperature. And then, of course, if you want to go the other way, take Fahrenheit, subtract 30 from it, and then cut it in half, and that basically gives you the metric. So, for instance, 32, right? Take 30 away, that gives you 2. Cut that in half, that gives you a 1. Well, you know that it's supposed to actually be 0, but you see how it's pretty close? Take 30 away from that, cut it in half, and it's nowhere close to 100, because, again, it's a gross approximation. But it's, you know, close enough. Okay, so what are the precise conversions? The metric system is beautiful because you can go from a length to a capacity to a weight, and they're all related very nicely. So a volume, right, a capacity, 1 liter of water takes up 1,000 cubic centimeters, but it also weighs exactly 1 kilogram or 1,000 grams. So it's a nice way that everything is kind of put together in that system. Just to remind you, if you didn't look at any of the other videos, here are, you know, how things work with all of these Latin prefixes telling you whether or not it's a power of 10 in the positive direction or a power of 10 in the negative direction, meaning does it get bigger, right, kilo, or smaller, like centi. If you want to convert from one metric measurement to another, it's really easy because all you're doing is moving the decimal place. I mean, it's really that simple because they're all related by powers of 10. So if you wanted to take each of these and write them as the other, so like kilometer in another prefix, so we're given 43 kilometers, well, that's 430 hectometers, 4,300 decameters, 43,000 meters. And then you keep going. Decimeters, centimeters, and then millimeters. Just keep adding zeros, right? Start with 60 liters, do the same thing. Decaliters, right, is 6. Hectoliters, right, we're getting smaller, right? We're moving the decimal because we're getting a bigger measurement. And then kiloliters, if we go in the other direction, down to centiliters and milliliters. And then, of course, CG is centigrams, decagrams, grams, hectograms, and finally up to kilograms. And you can go in the other direction as well. So I'm not going to spend a lot of time on these because you can see that it's just moving the decimal place one way or the other. And that's what's really the beauty of the metric system. All right, guys, that's everything we need to know for miscellaneous measurements.